For a long time in the United States as well as the rest of the world, the single biggest source of renewable electricity was hydroelectric power. In fact, hydroelectric power was the first major form of electricity in the United States that was transmitted over a long distance, being more than just a few miles. And that was at Niagara Falls. Hydroelectric power essentially works by harnessing the energy when water drops. The first example of a large hydroelectric power plant in the United States was at Niagara Falls. Now, when you have a waterfall, you have naturally water dropping. And so what they figured out they could do is set up a plant that would take the energy from this water that was dropping through the falls naturally and convert some of it to electricity. Now, this doesn't really have a significant effect. It would tend to keep the waterfall from changing its location some, but you're not going to cause a large-scale ecological damage of some form by keeping the wildlife separate or something like that that would happen from a dam, which we'll talk about later. Really, you're harnessing what's already there. The problem is you're taking some of the water from the waterfall, which is not generally considered a good idea because people really like to see waterfalls. Niagara Falls is one of the most picturesque waterfalls in the world, and people come from all over the world to see it. So you can't divert all of the water that's going through there. Now, it turns out that they actually will increase the flow of water during the evening hours when nobody's there to watch the waterfall. And so that way they can generate more electricity from there. They get less during the daytime hours because people want to go see it. But it is still a very valuable form of electricity. Now, there's a limit to how many waterfalls that can exist in nature. There's just only so many, and they can only produce so much power, and people like to look at waterfalls, as previously mentioned. So you can use an artificial waterfall in the form of a dam. Now, dams are built in rivers for all kinds of reasons, many of which have nothing to do with electricity generation. They're used to prevent flooding, they're used to keep a channel navigable down a river or stream, they're used to assist with irrigation, and they're also used to keep a steady supply of water for a city or town that may need it, or in some instances even entire states, as some of the dams that go through the United States Southwest Desert are used for. Anytime you have a dam, you could theoretically generate electricity from it. Many of the smaller dams in this country and throughout the world are built in place for other purposes, and they don't actually generate any electricity whatsoever. In theory, we could go set up a small generating station at each one of these dams, run the appropriate lines to that, and we would be able to get power out of there, but it is not completely done. I forget the number exactly, but it's something like 20% of the current existing capacity could be generated from dams that are not actually collecting any electricity whatsoever at this point in time. First of all, let's talk about the construction materials themselves. Now, dams are made out of concrete and steel or other metals primarily. The metal parts can all be refurbished. The concrete builds for a long time. A properly constructed dam will last for a very long time. In fact, virtually all of the electricity that we are generating in this country from a power plant that was designed before the 1930s comes from hydroelectric power. And in fact, it's just absurd how much longer these last than anything else. They do cause some ecological damage. The first one comes from breaking up a river itself. Now, in many instances, this isn't really harmful. Many fish just kind of keep to a local part of the river, and building up a dam through the river isn't really going to significantly affect their terrain. In fact, they may be able to live in a wider area than they would be otherwise, because you tend to have more lakes and stuff that are generated through the building of these dams. But for some fish, this can be particularly problematic. The one in particular is salmon. Salmon have this life cycle where they will be born in the top part of a river, they'll migrate down to the end of it, maybe live in the ocean for a while, and then migrate back up to lay their eggs. And thus they have to be able to swim a long distance through a river. This is very, very important to their life cycle, and salmon are a very, very important fish throughout the United States. And thus it's very important to keep them secure. And so we have to take that into account when we choose where to build dams to allow these fish to be able to grow. You can't also build a dam at just any other location. It has to be a particularly good one. Canyons and stuff will tend to work better where you have a natural dip, although rivers tend to generate those with time, so they're not too bad. It can cause some other issues. The land will tend to be filled with water in the area nearby. Whatever was there will be gone. Most of the time this may not be a huge issue, but it's something to certainly keep in mind. And there are some areas such as the Glen Canyon Dam that have been considered as possibly particularly damaged. I'm not going to speak to whether or not that was really the case, but it is an issue that's frequently brought forward. Another interesting thing happens that when you release the water, you don't release it from the very, very top. You release water that was somewhere down through the process. And water on the surface tends to be much, much warmer than water that's lower down in the surface because water takes a long time to heat up. And if you ever watched a pot boil, you know this. Releasing the cold water from the bottom or wherever it is down to the very shallow river that comes out of the dam will tend to cause some fairly significant issues because of shock. The cold jarring with the heat can cause some issues to some of the wildlife that's in that area. Something to be aware of. It's not a huge concern, however. The biggest issue by far, though, for humans directly is when one of these dams breaks. Now, I grew up in southern Idaho. There, they had one of the worst disasters in the United States as far as dams breaking. The Teton Dam broke, and a lot of people that I know were affected by that. But dams breaking has caused as many as 100,000 lives with the most severe instance. So this is something that needs to be managed carefully. Now, if you're taking proper care of the dam, you're inspecting it, you're doing everything right, you can make it work. It's also worth noting that there are some areas where you need to run these dams, and the safest way to let the water from the higher level to the lower level go is running it through the hydroelectric generation part. You can have it go over a spillway, but that may cause some other issues that you don't really want to do, and it can just be a bad thing. So sometimes these plants will actually have to generate electricity. And that can cause some other issues in grid balance where you have a source of electricity that needs to produce energy or else some negative consequence will happen. There's one other thing that can happen that's worth noting. When you have something that dies in a river, the natural tendency is for it to keep flowing down until it hits the ocean. And there's always something that can gobble it up. Well, if you have a dam, you're breaking the flow of those sediments and stuff. And you'll have maybe a fish that will die, will come down to the bottom, and it will not be flushed out to the ocean like it would be normally. And as it decomposes, it creates methane. Thus, even a long-running dam produces a very small amount of greenhouse gas because methane is a fairly potent greenhouse gas. It's something to be concerned about. Overall, though, hydroelectric power is the cleanest form of electricity we have. We can't build it everywhere, but it is a very, very useful form of electricity, and it's something that I think we should continue to develop where we can. We could take advantage of the fact that we have a number of these dams that are not generating electricity. It's essentially almost free electricity. We just have to build a little generator there. And granted, there's some economy of scale there. You have to maintain the generator for a lower amount of electricity, but you have to maintain any form of power. We could certainly take advantage of that. But overall, hydroelectric power is a fantastic form of energy. Thank you guys very much for joining me. Let me know whatever questions or comments you guys have. Until next time, keep on tracking. Take care. First of all, let's wait for the airplane to pass overhead. Who would have known during COVID-19 that there's still airplanes that fly overhead?